Question number 23. In a double slit experiment, when I say double slit, what does it say? YDSC is your double slit experiment, Young's double slit experiment. The following intensity pattern is observed for light of wavelength lambda. Okay. So whenever you have a double slit experiment, the intensity should actually look like this. Right? Uniform intensity. But what am I observing? See, the intensity is rapidly reducing. So if I take these peaks and join them together, see, I get an intensity like this. What do you call this line as? The curve that I have drawing over here. This we call it as a modulation, right? So somewhere it is getting modulated. Where do we find these kinds of curve? We see this in case of a single slit experiment, right? That's what we see. Okay, but it's a double slit experiment, right? Distance between the slit is d. What can be deduced about the value of lambda by d and the effect of single slit diffraction in this experiment? Okay, so now what we do is now I want lambda by d. How do I get? First, what we'll do is we'll write beta is equal to lambda into capital D by small d, and we know the angle of diffraction theta is equal to capital D divided by d. So which should now be equal to lambda by d, right? So which means if this is 0.02, then this value would be 0.01. See, because you know 0.02 is this peak. This is 0.04, this peak. This peak should be 0.03, right? 0.01, and this part would be 0.01 divided by 2, which is 0.005. I am writing it like this. Then 0, then once again this would be 0.01 divided by 2. Now what is he asking? The width of this one. So theta. This theta is nothing but this width in angles, which should now be equal to, when I add these two, what do I get here? I get the answer 0.01. Thus the value of theta, which is lambda by d, should be equal to 0.01. So this should be your answer. Okay. So as a result of this, this goes wrong, this goes wrong. Any one of them should be here. And then finally, single slit diffraction. What is asked? And the effect of single slit diffraction in the experiment. See, for some reasons you observe that this lambda by d is not seen to have an uniform intensity pattern like this, but instead the intensity is seen to be decreasing with respect to as we move away, which means if you have a single slit diffraction and you are at the center here, what happens is here you might get a much larger intensity, but as we move away from here, the intensity starts fading down, right? The same thing is seen to be observed over here. So as a result of it, this cannot be neglected, and hence the answer is B over here.